Hey friends, today I had a little incident while tuning my 2-inch DredCine CineWhoop, and this gave me the opportunity to actually do a build video. So today I'm going to assume that you already have your electronics soldered, because I have other videos that are showing that. But let me show you what we have here. We have a Tune RC Poly F405 flight controller, and I like this flight controller because it's an F405 and it has lots of outputs for us to use. It has plenty of memory. It's a little bit faster than the 411. It's a good middle ground between the F411 and the F7. So great flight controller, love it. The motors that we're using here are, I fly these on 3S. These are RCN Power, the GTS version 3, 1303 8000 kV motors, and I really like these. They're really pretty cool. The other components I have here is let's see, using a Happy Model ELRS EP2 receiver. This is a nice small receiver. It just tucks right inside there. And I'm actually not using a VTX yet, but other things that we'll have here is the GEP M10DQ. This flight controller does not have a barometer on board, so we're going to use the DQ model of this GEP GPS module, because it has, as well as the GPS, it also has a barometer and a magnetometer, so that we can get all of our sensors in onto INAV. Now, this, if you so want it, is a Tune RC buzzer with built-in circuit driver. This flight controller does not have a driver on the buzzer pad, so you have to use one with a built-in driver, and this one is specifically made. It's a Tune RC product made for their Tune RC flight controller. We're going to later add this this Miko Air optical flow piece here, optical flow and rangefinder. So with the addition of this, we have all of the flight control sensors that INAV will take advantage of. This this frame, here's what it looks like, built and put together, was one that I designed starting about 2 years ago. And folks have said that it looks kind of like a GEP RC. Well, I've flown a lot of GEP quads, and I learned to fly on a GEP Cinelog 30. I then bought a Cinelog 25, and I thought I'd really like a Cinelog 20, but they didn't make one 2 years ago, and so I started to design this to be what I think should have been what they put out as the Cinelog 20. So the nice thing about kind of being inspired by a GEP RC product is that we can use a lot of the GEP add-ons to go into this frame. So for example, if you want a GoPro 8 seat to sit on top, you can use it. I actually designed this VTX holder, which is a TPU piece, but it is very similar to what the camera holder is for the Cinelog 25 and the Cinelog 30 series. So these mount holes are the same distance. You could actually buy aftermarket parts for GEP RC quads that would fit this as well. You could buy the Cinelog 20 or the Cinelog 30, excuse me, the Cinelog 25 or the Cinelog 30 camera mounts that would match this. And these prop guards are also from GEP RC. This is, it comes off of one of their 2-inch CineWhoops that I think it was a CineQueen or something like that. And they sell a lot of these available in the aftermarket, because these, I think, also fit their Cinelog 20 as well. But you should be able to buy this frame soon at CNC Drones, so that if you want to follow along and do your own build with it, you'll be able to get that frame for you. Now, this frame comes with a carbon fiber bottom piece, and I have additional 3D prints that allow you to mount either a Naked O3 into here. You could mount a standard 20 by 20 VTX into this piece down here. You could, on top of the flight controller, mount a 35.5 inch VTX on top of the flight controller or underneath it, depending on how you're looking at the drone. And for example, you could use a Walksnail. I have a lot of Walksnail versions of this that just fit right into the quad, no problem. The Walksnail 4K fits in here also with a special mount, and I'll show you that. It's a 3D printed piece that connects to this 20 by 20 mount area, and then you connect a Walksnail 4K kit onto there, and you've got a great 2-inch quad with Walksnail 4K on it. As I said, it also fits the Naked O3, so you could build almost anything with this. This is a custom designed 3D printed mount for our GEP-RC GPS, barometer, and magnetometer. And then I said this has a carbon fiber bottom, but when we're mounting this MECO Air MTF-01 rangefinder and optical flow meter, well, we've got to get that through here. So I've got a 3D print that fits this MECO Air just quite nicely, and it sits right here and replaces this piece on the bottom of this this bottom plate right here. So we take this bottom plate off and we use a 3D printed version. I'm using PLA for this. If you really wanted to, you could print that in PETG and get a little more durability out of it. Here's our electronics. I've already done this. I've already put this together. This as well is a custom 3D print. This is in PETG. You may want to use PETG. All this is a cap that fits a standard 35 by 35, 35.5 millimeter flight controller mount, and you can use this to, zip tie receivers onto it, zip tie other types of components or wires to keep them out of the way. So it's just a little 3D printed receiver mount. I'll have this available for download as well. So what I've done here is I have left serial 1 open. The serial 1 port, serial port 1, we're going to use for a VTX in the future. Here is the serial 2, and that is where our receiver goes. So I've connected that up, 4 wires to serial 2 for our receiver. This is the Happy Model ELRS receiver that I have pre-mounted in here for you. I have connected this 4-wire connector, which is on serial 5. This goes to the serial port 5. This goes to our MECO Air, which is a 4-wire connector, 5 volts ground in RX and TX here on a UART. So GPS is here on R3, T3, as well as the serial data and the serial clock for our magnetometer. So more connections than you would be able to do with an F411. So we're definitely using more serial ports. You need the F405 for this or an F7, but I don't see a need to have that, an F7 for an all-in-one. This is a 20 amp all-in-one that just works beautifully for these smaller builds. So the first thing you're going to want to do is put these vibration dampers into your camera plate. Even if you're not flying with the VTX yet, I'm flying this line of sight because this is my first time using INAV, and I'm wanting to understand exactly how to tune it, how to set it up well, and maybe that would be easier with a VTX, but I really want to be able to use this as a STEM kit for high schoolers perhaps who may not have the money to buy digital goggles and VTXs. And so, but I'm going to mount this plate on here anyway. And the reason you want this is because you could still put a GoPro, like a GoPro Bones or Naked GoPro 10 or 9 on top of here and get great video without even having a VTX. Now, these are a little bit of a pain. Basically, the trick is that you take a little bit of dental floss, feed it through the hole, and then pull the piece back in here. We're going to make sure we get the holes facing up because this is the top of the drone. So we're going to come up through one of these arms. I'll probably go have this on fast motion so that you don't have to watch me struggle with this for too long. But I'm going to wrap that around there and then pull it through. It's as easy as that. Now you get to the second, the third, and the fourth, and it does get a little bit harder, but let's go ahead and do it. Sometimes tweezers make it a little easier to wrap around. There we go. All right. It can be a little bit frustrating, but there we go. There's the beginning of the build. Now, the next thing is our mounts for the flight controller. And this is a looks like a 15 millimeter or so screw for the flight controller. We're going to come in through the flight controller holes from the top down, put a 1 millimeter plastic washer on that. These are M2 screws, and we're going to use a metal M2 screw. Now you could, or excuse me, a metal M2 nut here. You could use a plastic one if you wanted, but I find the metal one holds nice and tight. And since we're using a metal nut on top of this flight controller stack screw, we're going to add on top of that one more 1 mil spacer and a plastic one. So let's tighten that down. We want that good and solid because we don't want that flight controller bouncing around here. So we're going to use gummies to soft mount it. So that is where the flight controller will sit on top of that. Stacked mount is right above this big hole, not up on the top there. That is for a standoff. Now we want to put 25 millimeter M2 knurled standoffs. If you are not using a VTX, or if you're using like a little Walksnail 1S VTX, then you're going to want 25 millimeters. If you're going for something bigger, like a Naked GoPro or a 4K Walksnail, you may need 35 millimeters or even potentially 40. But this one is nice and small. Now this one up here we get to by squeezing that, and then we can get to screw on this. So we can get to it by squeezing that down, and then now we've got a nice tight fit. This one is easy. Now you remember your standoffs are going to go right next to these, vibration dampers. And this is a 7mm holder. You could really use any length you wanted here, but a 7mm M2 screw is just fine to hold these in place. And you want the button top ones because you see I've got nice countersinks in here, and so these button tops fit almost flush with the top up here. All right, so we're going to leave the fourth one out. Don't put that fourth one in yet. So the next thing we're going to do is give ourselves some plastic spacers. We want these spacers both to give us a little bit more room underneath the flight controller for the power cables and the USB cables, but we also want to keep the metal, insulate that metal away. Looks like I've lost one. So one 1mm spacer for each of those. We want this arrow of the flight controller up because we're building upside down. So since we flip that this way, and we want this USB to be up against there, we're going to have some room, and we're going to put this down in here. Now, your motor wire lengths also you need to be very careful of, because you don't want these motor wire lengths too long. This is like just about 1 inch, 1.5 inches there or less. So this flight controller, I've gone ahead and put my gummies in here. So I already have the gummies mounted in this one. And we want to just slide it on there. Now let's make sure we've got plenty of space here. We've got plenty of space. This is why we wanted a spacer on here that's plastic, because this positive side of the battery connector goes right on there. And so we want to make sure we don't get any contact with the metal. And then we've got plenty of room here for the USB connector. And so keep in mind, this pointed edge is the back and the flat edge is the front of the drone. So we get our motors over there. And now I'm going to go ahead and fold over this 3D print. That's right now, all it's holding is my receiver, and it's going to hold on to here and push down. Like such. And this is made of PETG, so it can handle a little bit of heat. If you want to, and I may, that should be okay. If you wanted to, you could put an additional 1mm spacer in there, but this looks okay. I've put the receiver on a JST connector so that if you wanted to switch this out for crossfire, something like that, it's easy to do. Now we're going to take 4 nuts, and these are lock nuts. So the other thing I have here, all these are is spacers. This is a build aid. It's going to allow us to put our motors on without having to put our prop guards on yet. So these are 6mm motor button top M2 motor mounts, and I'm going to use a spacer. And putting these motors on with this spacer just lets us build without these motor wires flopping around. And using the spacer makes sure that we don't ruin the windings of the motor. So I'm going to get that hose in for the motor and you want to you might be able to find the parts. This thing a little bit. What we want to do is get our GPS in here. Now I'm going to take this apart so that you can see this. This GPS unit kind of snap fits into this print. And I want you to be really careful and make sure that you have your foam in here. And there's a little ridge inside of here. And this ridge catches on the antenna edge or the PCB here. So we're going to take this. There's also, by the way, there's a little channel and a little hole in the back of this where you could mount an ELRS antenna and have that running through the channel through here. So it's kind of a nice little extra bit to that. And we're going to fit this down in here. Get it up underneath there. We want to get it mounted to the back, but we want it above, so we want to slide this through here, and that allows that to mount up there with that. But what do we do with our GPS wires? Well, these wires, I want them to be kind of going through, okay? We want it to go through here. And then up the back and connect there. So it's really, really difficult, kind of tight, but that's going to come up through here.
Hey y'all, it's Jamie from the future. I did a really bad job of framing the shot so that you could see how I put the GPS into this quad. So I've taken this back apart partially so that I can try to give you a better view so that you can follow along and hopefully make sense of how I got the GPS in here. So here we go.
And what we can do is bend this over. And connect the wire. Now, we want this to come up on the other side. See, right here is where our USB connector is. So we want these wires not to obstruct the USB, but to come out the other side. So we want this to push down through here. Now we have our wires coming up. USB is on this side, the wires are coming out this side, and this little holder is where we now slide the standoff into. And the standoff is going to be anchored right there. So this is going to hold our standoff in place. We're just going to hold the GPS in place. Now make sure you're not pinching any wires underneath there, that all the wires are coming out, kind of straight down, in between. Yep, that's looking good. Tighten this on down. And now again, make sure you're not pinching any wires in between the frame and the standoff. You want those wires coming straight out the back and down. And we'll be able to tie wrap that wire to keep it from getting loose. Now you've got these two holes here, which you're going to use either a 5 or 6 millimeter screw with a nut on the end of it. And when you're done with your final build here, you may choose to put a little bit of blue thread lock in there to make sure that this locks in place. You want to make sure this isn't too long, because if it's too long, you could come in contact with your power lead there. And you don't want that to eventually eat off the, or eat kind of through the insulation of your power wire. Now this is a bit of a pain. On top, I got it. There we go. And again, if that sticks out a little bit, it's okay, but you need to be pretty careful to make sure that it's not going to be in constant contact with your positive wire there and eat through, and because we don't want this frame to be hot. I would recommend a 5 millimeter here. I think these are 6 mil and they're just a little bit too long, but it's good enough for now. There's your GPS map. This piece plugs in here. The nice thing about this sensor is it's labeled ground voltage RT. And let's put that a little bit tighter, and that will go there. So this is another 3D print part, and typically I would have just connected this, but we need a little bit of standoff here. We need a little landing pads. Voila, there we go. Let's finish up by replacing these spacers with our prop guards. Now remember, we were using these spacers only as a build aid. You don't really want to fly with these. Your props may catch some open wires. It's just not designed to fly that way. And the thing to remember about the prop guards is that there's a square pattern on here that you need to find where the pattern is square and one of these arms is pointing up straight perpendicular to one of the edges of the square that those motor mount holes create if you were to draw a line to put them together. If we flip it this way, you can see that this is off-centered from the bar sticking straight up. If we rotate it here, these motor holes are off-center from this part of the prop guard. If we have it this way, we see that these two motor holes, if you had a line between them, are directly perpendicular from this part of the prop guard. That line needs to line up with an arm. So this line, if you imagine that it's just going all the way as an X through the quad, that's how you're going to line these up. We're going to remove the spacer, set that aside. We don't need it anymore. We're going to find the part of this prop guard that if you were to draw a square using these four holes, one of these pieces is going to be directly perpendicular to the edge of that square. And we're going to line that up, pointing directly in line with this arm. We are going to take this motor and let it just fall down into that hole. Then we'll line those four holes in the arm up with the four holes of this prop guard. And let's put one of these screws through here to hold it in place. And then take that motor. We may have a twist or two of that motor wire to keep it a little bit from hanging too loose. We're going to take that and put it into one corner. Make sure that that lines up straight across here, and that we can take a second screw to hold the next corner in place. Now be gentle with this. You don't want to get these too tight. We're just putting them in place to hold them for now, and then we'll tighten them all down later. When you're done with assembly, or as you're finishing up before you start to go fly this quad, you may decide to put a little dot of blue Loctite on here so that it holds good and tight and doesn't come loose and doesn't create any vibrations in the drone. So one more time, we're going to take this next motor off, remove the spacer, and we're going to line up one of these three parts of the prop guard straight out. There it is. If you were to draw a line between those two holes, there's a piece of this prop guard that's perpendicular. Your motor is going to slide right down through this hole. Let it fall down into there. And now, notice the line from here to here. The important thing about having these lined up this way is it gives us a nice little pocket in here for the VTX camera to sit right down in here and not have these parts of the prop guards actually in the way. The same thing for the motor wires themselves, is you have a nice little pocket here for the motor to fall into and the wires not to be obstructed by either one of these parts of the prop guard. We are going to fly with a props out flight pattern. So that means that this is the top of the prop, this is the bottom. You can perhaps notice that there are two dots on here, and this has a little bit of writing that you can feel on top of that. This is up, and so when it's sitting in the quad, that's up. This is the leading edge of the propeller, and that is going to rotate clockwise from the top. This is going to be pushing air down when it goes that way. If we rotate that up, this propeller will fit here. So, props out configuration with the two dots facing down. There's a little bit of writing up here on the top sometimes. And this is a props out configuration quad. That is props out. If we line, let's see. This one should, if it looks the exact same as the one in this corner, we should be able to take it straight over to this corner and set that up as props out. We can see as this is spinning, this is the leading edge, this is the top. As this rotates, it will push air down. There's no writing here. The writing is, there it is. You can feel it. That's the top, so we have to flip it upside down. Now we are in props out, props out, props out, props out. We're good to go. Let's line these up. These will be 7mm screws using this particular motor with this particular prop. This is a Jamfan Hurricane 2023 prop, and their hub is a little bit thicker than some other props, and so you need a little bit longer screw to hold those in. This is 3M dual lock. It's very strong, stronger than Velcro. If you're doing anything crazy, you could use both. You could use a strap and Velcro, or just the strap. But I like this for simplicity.